Okay, so the math problem that I came up with for this one is negative 2x plus 4 is equal to x minus 2. It took me a little while to come up with a math problem that would work because it kept coming up with ones that when I would try to solve it, I would come out with a fraction. So it took a little playing to come up with a good one to be able to use with the algebra tiles. So in this first example of how to solve it, I'm going to be removing 0 pairs, or I guess technically adding 0 pairs so that I can then remove things. So first I wanted to get the x is over onto one side. Since the side already has 2, I want to move this one over here. But since we have to keep it even, since it's that seesaw, we want to make sure that we're removing the same amount from each side. So I added a 0 pair of x. See, it's got the negative x and then the positive x, so it's a 0 pair. It cancels out. So we're going to go ahead and remove from both sides, keeping it even, a single x. See, they're connected. We remove them, and it's keeping everything the same. So then we end up with this extra x, negative x over here. So now I want to do the same thing with the ones, but I want to get them to the opposite side because we want our x on one side and our number on the other side. So I've got 4 positives here, but I don't have any positives here, so I can't remove these. So once again, we're going to do the 0 pair. So I add 4 sets of 0 pairs. That way I can remove 4 positives. My ability to highlight is terrible today. I apologize. So there we go. So now I can remove those 4 positive units from both sides at the same time without it affecting it. So now we're left with negative 3x is equal to negative 6. So let's go ahead and change everything to a positive because we can use the value where we flip every term over. So boop, boop, boop. Changing everything to a positive because it doesn't actually change the value. We're just basically times it by negative 1. So now we have 3x is equal to 6. Well, that can be easily divided by 3. So let's go ahead and move these and move these. Whoops. And so then you can easily see x equals 2. So that's how I solved it the first time. So the second time, because we wanted to try and do a different method, I went ahead and just did adding the same value to both sides instead of adding 0 pairs or removing 0 pairs. So, but I basically wanted the same process. I wanted to get all the x's onto this side, and I wanted to get all the units onto this side. That way we can find out what the answer is. So I started by adding a negative x, because that makes it so that this x would cancel out. So we added a negative x to both sides. See, they're still connected. And we're adding them at the same time so that we can see that we're adding the same value to both sides of the teeter-totter seesaw. And then we can go ahead and remove this pair because they cancel each other out, so we don't need them there anymore. So we're going to take them down here. So now we have no x's on this side, and we've got negative 3 x's on this side. So then we're going to do the same thing for the ones. We want to be able to take these 4 ones and move them onto this side. So we have to make them even. We have to do the same change on both sides. So we're going to add 4 negative ones to both sides. See, they're connected. Once again, we're adding the same to both sides at the same time. So it's easy to see that we are adding the same thing, keeping the seesaw at the same balance. So now these 4 cancel each other out. We've got 4 positive ones and then 4 negative ones. So they cancel each other out, and we bring them down here because we don't need them anymore. So then we have negative 3x and then minus is equal to negative 6. Well, we can easily divide that. So we're gonna split these up because these divide up nice and evenly. So we can see negative x equals negative 2. But we don't really want it to remain a negative, so let's go ahead and times everything by negative 1. So we flip every term. This, once again, doesn't change the value, doesn't change the balance or anything. It's just flipping everything over, timesing it by 1. We don't change the information when we only multiply it by 1 or divide it by 1. So now we have 3x is equal to 6. And you can see, once it's split up into even ones, once again, x is equal to 2. And that is how I solved it.